Hello, Arthur here. I love to draw. When you draw, you use paper. Paper is nice and smooth and flat. Or is it? Although paper may appear flat to us, when you get down to the microscopic level, it actually isn't. A piece of paper to a microbe is a vast landscape of mountains and valleys. So if paper isn't actually flat, is anything actually flat? What is the flattest thing we know of? And what is the shape of the universe? First off, we're going to have to define flat. The Cambridge Dictionary defines flat as being level and smooth with no curved, high or hollow parts. Essentially, a non-curved surface with no roughness on its surface. Let's start with the Earth. The Earth is not flat, despite what some people might think. And even if the Earth wasn't a globe and was instead a disc, it wouldn't be truly flat, as here on Earth there are mountains and valleys and hills and cities that we humans have built, which these have given Earth's surface a roughness to it. The flattest place on the surface of the Earth is the Uyuni salt flat in Bolivia. At this place, the highest peaks and the lowest valleys are only several millimetres in height or depth, and it is so flat it is used by satellites to calibrate their equipment. A candidate for the smoothest object on Earth is a 1 kilogram sphere of silicon-28 located in Australia. If this sphere was scaled up to the size of the Earth, the highest peak and the lowest valley would be 14 metres apart. The flattest material ever found is graphene, which is carbon atoms bonded together in a single sheet, one atom high. Graphene is also estimated to be the strongest material, 100 times stronger than steel. Now that we have found the flattest material in the universe, let's talk about the universe itself. The shape of the universe is most likely flat. When we say the universe is flat, we don't mean two-dimensional. What we mean is that in space, parallel lines will never meet. On a flat surface with zero curvature, parallel lines never meet. Whereas on a sphere with positive curvature, parallel lines converge, and on a Pringle or saddle with negative curvature, parallel lines will diverge. On a flat surface, the angles in a triangle add up to 180 degrees. And on a sphere, the angles sum to greater than 180 degrees. And on a Pringle, less than 180 degrees. The same principle is theorised to apply to our universe, only one dimension higher. Our universe is either a three-dimensional plane or the 3D surface of a 4D hypersphere. That may be hard to imagine for our three-dimensional minds, like a blind person trying to imagine colour. The idea of moving in any of the 3 dimensions and ending up where you started sounds impossible, but it is mathematically possible in 4 dimensions. Space telescopes, such as Planck, have studied the cosmic microwave background and have found that the angles of triangles added to 180 degrees, and have used this to conclude that the universe is flat. However, we don't know how big our universe is beyond the observable universe. It's possible that on the scale of our entire universe, distances like those seen in the CMB are insignificant and would therefore result in the appearance of our universe being flat. Much in the same way, Earth appears flat over short distances. Because of this, a better way of showing the universe's flatness is by working out the critical density. The critical density is the average density of mass and energy in the universe required for the universe to be flat. Mass and energy bend space-time. So by our earlier definition of flat, the universe is not flat, as there are regions of space that are curved by heavy objects. But much in the same way we call a piece of paper flat, even though it technically isn't, a 4-dimensional Titan would call our universe flat in the sense that they could place their 4D hands on it and it would feel flat. The critical density for our universe is around 5 hydrogen atoms per metre cubed. If the universe was slightly less dense, it would have a negative curvature, and slightly more dense, it would have a positive curvature. The critical density of our universe will also determine another thing, and that's the fate of our universe. There are 3 proposed ways our universe could end: the Big Crunch, the Big Rip, and the Big Freeze. In the Big Crunch, the universe would eventually collapse back in on itself from gravity overcoming the acceleration of the expansion rate. This theory also suggests that the universe could keep dying and being reborn. This is considered the least likely scenario, however, as it would rely on the expansion of the universe reaching a hole and then reversing, causing the universe to collapse, which would be the case in a positively curved universe. But since our universe is probably flat, the Big Crunch is unlikely to take place. In the Big Rip model, the acceleration of the expansion of the universe would get so great the universe would be ripped apart. People, planets, stars, and even atoms would be ripped apart. This happens because the rate of expansion accelerates so much it overcomes the force of gravity that keeps stars and planets within galaxies together. If this were to occur, it would cause space to expand faster than light everywhere and result in no 2 particles being able to interact. The most likely fate for our universe, given that the universe is flat, is the Big Freeze, or the heat death of the universe. In this case, the rate of expansion would also continue to get faster, and the universe would expand forever. But the overall entropy in the universe would increase and result in matter and energy being evenly distributed throughout the universe. At this point, nothing new could happen and the universe will just be a giant sea of subatomic particles with no way of interacting with each other. This will happen in around 10 to the 100 years. It may sound depressing to think that everything will just end and that the universe will be dead and nothing forever. But there is some hope. As I have mentioned before, it is possible that over grand timescales, small energy fluctuations could lead to a decrease in entropy, causing objects such as this mug or this polystyrene ball to be randomly produced from the chaos, and could eventually lead to another high density, low energy point being formed, much like what caused the Big Bang. So regardless of what shape our universe may take, there does seem to be some hope that it could be reborn. Thanks for watching.